Many are surprised, and perhaps you were not aware either, but when you deploy a service in Azure, more often than not, this is a service that is publicly available on the internet. This means you have public-facing endpoints where you could allow traffic to come through. So most PaaS services do this. For example, if you deploy a storage account, you are going to have public-facing endpoints. And this is great if you are setting up a quick POC, like a proof of concept, or if you're going to do a demo, or if you just want to test something real quick. It is less ideal if you are in an enterprise setting. But luckily for us, we do have a solution to this, and it's called private endpoints. Hello, my name is Carl Lindberg. I'm a Microsoft MVP here in Sweden, and I have a focus on infrastructure as code. I run this YouTube channel where I post a lot of things, not just Azure, but mainly Azure. But before we dig even deeper into this, I think there is something we need to address first, which is a question I receive a lot, which is what is actually the difference between private endpoint and private link? So basically you can think of private endpoint is at its very core is just a network interface card. It's a network interface card that you can attach to a virtual network, or I guess the word is you place it inside a virtual network, and this virtual network and this network interface card is going to be attached to a PaaS service. So PaaS stands for Platform as a Service. So think of your Azure SQL databases, think of your Azure storage accounts. I can't think of any more, but there are a lot of them. Just trust me, there's plenty of PaaS services. And you could say then that is private endpoint. And what is actually the overarching technology that makes all of this possible is private link. So you could say that private endpoint is a sub-service or subsection of private link. You wouldn't be wrong if you were to say that. But that's basically like the 80-20. There's much more to it when it comes to private link, but we are focusing for this video right now on private endpoints. And like I mentioned, this is super great for us if we want to use our platform services, but we want to make them available privately and want to make sure that they are not accessible from the public internet. And they're also great for us if we are in a hybrid environment. So perhaps we have an on-premise location. We could set up with a site-to-site VPN connection, for example. We could have the possibility to contact our private endpoints from machines and services and things we have on premise with a conditional forwarder, for example. So let's say we have a storage account and it's placed in Azure, and we have a private endpoint placed in a virtual network in Azure. We could, from our on-premises, make sure that any requests coming towards file.core.windows.net service for Azure storage files, for example, this could be forwarded to the correct location somewhere in Azure. There's much more to it than just that, but that's also like the overarching thing that you could do. And then it's a very common scenario I find when working with customers who have hybrid solutions. So this is what we're going to set up today. We're going to have a virtual network with some subnets, and I also want to create a storage account, and we're going to make sure that we deny public access on the storage account, and we're going to register a private endpoint. And we also want to make sure that this can be resolved, because we don't want to work with IP addresses. We want to make sure we use DNS, and to help us with that we can use something called private DNS zones. So we're going to create one for the blob subservice. So for storage account, for example, you could have subservices of blob, file, queue, and table, if I recall correctly. And we're going to utilize the VNet link, so we can link this private DNS zone to this virtual network, which means any endpoints in here, when they do name resolution and they submit any queries for anything that fits this private DNS zone, it knows where to send this traffic. So let's get started. I've done a little bit of home cooking, so I've prepared the variables that I am using for this. If you watched any of my other videos, you know that these are the ones I usually prepare in advance. I have a tf-vars file, so we're going to assume we're working with a production environment here, but location short and location stays the same. You could actually do like, instead of having just a prod.tf-vars, we could do a common.tf-vars, and then you could take these two and move them into the common.tf-vars. And why would you do that? Thinking about this is you have a few variables which are going to be the same regardless of environment, so they can be in common.tf-vars. And then you have production TF-vars, where you would have production specific variables. For us right now, we are only going to set the environment, but you could have things like my dev environment. I want this virtual machine, for example, to have X amount of storage on it. It's going to be this amount in dev, like 50 gigabytes, and it's going to be 150 gigabytes or 250 gigabytes in production. And then we can supply those different values inside the tf-vars files, and we can keep the main.tf the same regardless of environment. So we just input whatever we put into the tf-vars files, basically. But that's not the main goal of this video, but I just wanted to mention it. So what it looks like here, I've done some preparations as well. I usually show you when I create the Terraform block and the provider block, but it's the same in every video, so I just prepared it. I've also prepared a resource group for all of this. Here you can see the string interpolation working, var.environment. Here, if I were to run this against my dev environment, it would not be rgprod sc, so location short is sc and pe. If I were to deploy this into the dev environment, var.environment would be equal to dev. But we're going to deploy this to production, so var.environment is going to equal to prod. This code block here in main.tf doesn't change regardless of environment. I hope that made sense. I don't think I explained that the best way I could, but again, that's not the aim of this video. But I think the first thing we want to have is we're going to make another resource, and we're going to say that this is a storage account, and we can say that the type is storage account. Name, we're gonna say SA as the prefix, and we can't have dashes in the name of a storage account, but we can still do our string interpolation, so I still want these two. And we're gonna say this is called Limburg Tech PE. This is just to make sure that the names are unique. So if any other storage account exists in Azure anywhere else in the world, I can't use that name, and I think if I didn't have the Limburg Tech, I may run into issues. Location, we're going to do var.location. The parent, we're going to put it in the resource group. It's parent ID. I like to put this one above location. And then we have to supply a body. So I think we do have some required properties. I don't know if that's how you're supposed to do it. Should we go like that? Or perhaps we do it here as well. Let's just say SKU. We're gonna say I don't really need too much here. We can do premium local redundant, that's fine. So for properties, I just want to make sure that I am saying that public network access is disabled. And we have to set a kind, so it's a storage v2 storage account. So finally, let's create the virtual network. We can say type virtual networks. Again, that should be Microsoft.network virtual network. So I just want to make sure we get the right one here. And the name is fine like that. I'm good with that. The parent ID is the resource group, and the location is still the location. For body, we're going to have to supply an address range. So it's an address space, address prefix, and we can just do a 10.10, it's 24. Pretty standard stuff. We could define the subnet inside of this this block as well, but I actually want to, I usually do that as its own resource. So we'll say subnet. Yeah, and the name. So we're gonna have if you remember from our drawing, we are trying to create two subnets, and we could do a little bit of a list for this. So we could say subnet config, perhaps. We'll say it's a list of objects. And this is kind of what I want. So I want a name and an address prefix. So the first one, it can be a 26. Yeah, 26. And the name here is not, doesn't matter too much, but we could do subnet client, for example. And then we'll make a new one here. We'll say subnet private endpoint. And I think that should be 128. That may be wrong, but we'll see. So then we could actually do a for each here first, where we are gonna, pretty much do that. So for subnet in local subnet config, we're gonna set subnet.name is the thing that is unique between these two objects. So that's gonna be the key. What we can do is set the next thing here. This is actually a good thing, which I've noted. I think this is an update, but for some resources when you create them, now if I do this, I get a code sample. If I just press enter, I get the remaining things that I have to give it. And it says also the ID of the Microsoft.network virtual network resource. And that's great because sometimes it wants the resource group as parent ID. That's usually the case for when you are creating a main resource like a virtual network. But now we are creating a subnet, which is it's a child resource rather of a virtual network. And then the parent ID becomes the virtual network. So we'll say that. The name of the subnet, so we'll just do each value name here. And I guess we could have done each key perhaps, but I'm gonna accept these as are, each value address prefix. So we get two subnets and they're gonna have different address prefixes. I don't think we need to do any export of any values. We'll keep schema validation enabled false. I will just toss that on here as well because it usually complains otherwise, and we'll do the same for the storage account. So I think I like what I'm seeing, and I think now is a good time to try and apply this. So if we're on a Terraform minute, I think there are some things I'm potentially missing in some resources, but I mean it doesn't hurt just trying to deploy this thing. So that worked. So we'll do a Terraform plan. Oops. This is what happens if you don't specify values for your variables, but luckily we do. So we do have var files for this, so we can say they are in our variables folder. It's called prod.tfrs, but we are also using an additional one, and we're looking at common.tfr. So you can use this flag twice, basically. Initially this looks promising, so we are getting a virtual network, we're getting a subnet, one called subnet private endpoint and one called client. And I guess this is a little bit redundant, so it'll be AC API resource subnet client. So we could actually say we're going to remove the subnet part. Also, it's already in subnet config, so we already know that this is a subnet basically. I like what I see. So we're going to run an apply and we're going to throw on an auto approve. So I have two problems with this. First off, I have a policy which doesn't allow locally redundant storage accounts. So I have to set that one to zone redundant. Why do I have that? Well, I wrote a blog post about Terraform and Azure policy, which I could link to in the description, but I just forgot to remove that. The other part is I was mistaken about the address prefixes. It is good if you place the number in its correct place. So my mistake. This should work now. And it was deployed successfully. So if I go into the portal, I have my storage account right here, and I have my virtual network. If we look into the virtual networks, we can see we have two subnets, so one for client and one for private endpoints. And if we look at the storage account, we can see right now if we go to networking, it is disabled as far as public network access goes. But then there is really no way to access this storage account right now. And that's where we have to create a private endpoint here, which I think is what we're going to do next. So back in VS Code, if we prepare a new resource and we'll call it private endpoint storage, we'll say the type is private endpoint and the name could be just like that, and it can have the name SA in the end. That's fine for me. This is a top level resource, so the parent ID should be the resource group and the location is still what we want it to be set to. So we have to supply a body here. And this is where it gets a little bit interesting. So there's a few things we have to set. First of all, we have to say in which subnet does this private endpoint get registered into. And there's a few different ways we can go about setting this. The easiest way to do this is just say we're going to put a subnet ID where we can point towards our AC API resource. You can see it already here, and we'll do subnet. And as you can see, so subnet in this case is going to be two different resources, but we created one for clients and one for private endpoints. But here we can actually target the one called private endpoint. And finally, we'll do a .id for the resource ID, basically. So after we've set the subnet, we have to set one more thing, which is called private link service connection. This is something that messed me up a lot in the beginning, because I thought that, do I need to have a private link service deployed and point to that in order to be able to use private endpoints? Or what is the deal? Luckily for us, we don't have to have that. We can actually point this right at our storage account. And the way to do that is you open a new object within private link service connections, like we've done here. And we have to specify a name. So I usually just take whatever I've written here. I don't know if that's the best practice or what you should do. It's just what I've done. Then we have to set properties, and we have to set a private link service ID. And here, like I mentioned, we can point towards the storage account ID. We also have to set something called group ID, which in our case will be blob. And this is just like how I mentioned for you with storage. When you create private endpoints, you can create private endpoints for blob, for file, for queue, for table. And depending on which one you're using, you have to pick the right one here for group IDs. But we're going to do it for blob, so we're going to put that. And then there is actually something we have to set, which is custom network interface name. This is just the name of the network interface card that gets created. So I'll put that as Nick. And we'll see if this one gets applied. So that seems to have been deployed successfully. Inside the portal, if you do a refresh here, we can see, yeah, we have a private endpoint attached to our storage account. However, if we go into this and look at the DNS configuration, for example, we can see that, yeah, the host name, which is the name of our storage account, .blob.core.windows.net, it does exist here, and it's been granted an IP address. And if you remember, this is the first available IP address that we have in our private endpoint subnet. And we can see this if we go to the virtual network and we go to connected devices. We can also see we have the NIC, or the network interface card, registered in our virtual network. And we can see it's attached to the correct subnet, which is awesome. But this doesn't help too much right now, because there is right now no way for us to be able to access the storage account, because if you remember, we disabled the public endpoint, so it's not accessible from the internet. But also, like, who is gonna access this address? Like, how are we gonna resolve that? I don't have a client right now that can talk to this storage account. So first off, we have to create an entry for this, and we're gonna do that with a private DNS zone. So in Azure, we can deploy something called, it's called private DNS zone, and I'm actually going to call this one blob. So in the future, if we were to create more private DNS zones in the future, we could do it for file and queue and yada yada yada. So this just makes it a little bit more future proofed. So the type is private DNS zone. The name in this case is rightfully so, private link.blob.core.windows.net. It's very important that you have this private link in the name. The parent ID is going to be towards the resource group, and we don't need to do much else with the private DNS zone, but we do need to have another resource, and that's called a private DNS zone blob VNet link. So if we do private DNS zones again, then you have a resource here called virtual network links, and the name is fine as that. The parent ID, in this case, the parent ID is actually going to be the private DNS zone. I think the location is global here as well, and then we do a body block with some properties, and here we have to say, so registration enabled. This one pertains to if you are creating virtual machines in the virtual network, if those A records should get registered in the DNS zone by default. In our case, we're going to set this to false. And then we have to specify which virtual network, and we've created this one in this project, so I'm just going to point towards my virtual network. And there is actually something else we do want, which we could do with Terraform, and that's basically just going to borrow that name and say a record so we can resolve our host name. So the type is private DNS zone A. The name here, I actually want the name of my storage account. The parent ID is the private DNS zone as well. And I just grabbed a code sample here. So we can remove a few things. The TTL is fine. We don't need to specify any metadata. But then we do have an A record, and here is the IPv4 address that we want to set. And then we have to set an IPv4 address. We will put that into there, which means we should get an A record that points to this IP address, and the name, if I've done this correctly, I'm actually doing this a little bit off the cuff, but if I've done this correctly, this name should be the storage account. I guess we could actually check that. So we could do a state list, grab the storage account, do a Terraform state show of the storage account. And here we see we have a name property. Is this one. So that's basically what I want. So that looks good. So .name basically on, where am I now? So .name here for the A record should translate into this. So we'll run an apply. So that was deployed successfully. If we do a refresh in our resource group, we can see we have a DNS zone for private link blob core windows.net. And we should see a record set. So now we have an A record with this host name that points towards our private endpoint IP address. And we can also see that we do have a virtual network link to the virtual network that we created, which means that when resources inside this virtual network does name resolution or name DNS queries basically, it should pick up on this private DNS zone being linked, and it should be able to resolve the host name correctly. And just because it's fun, I actually deployed a virtual machine inside the client subnet, which you can see here. And I just ran a NSLOOKUP towards the host name of my storage account for blobcorewindows.net. And as you can see here, I did get a response from the internal IP address of the private endpoint. So just to recap, this means that we did build this successfully, and we do have a client who has been able to talk to the private endpoint. The name resolution has been working properly because of our DNS zone being linked to the virtual network properly, and we could access our storage account on its internal IP. If you're interested in more Azure videos or videos on Terraform or both, because that's mainly what I do on the channel, be sure to check out the channel because there are a lot of videos out there which I think you would find interesting. Other than that, I am very grateful that you've watched this far. Remember to hit that like button and subscribe if you wish, and I'll see you in the next one. Thank you. Bye bye.